So now that we've promoted the things that we need to promote, we've established some properties that we want to use for our controls, and we've attached tags to our joints to inform how we want the functionality to work, whether something is a part of an IK system, whether something is a part of a left leg. We've done all of that, and now it's time to use these new attributes that we've created. And just as a reminder, we'll head over into the geometry spreadsheet so we can see these again. And we want, so here we have the name attribute. Here are those parameters that we've promoted, those properties. And then here we now have tags. And so you can see that all of these joints have been given tags. These joints have an IK tag in addition to a tag indicating what leg they are a part of. And all of those are just sitting on our points to be read by Apex. And then we send this in to a packed folder along with our base shape, our base skeleton, as our guide rig here. So here is our prepared asset ready to be rigged. So, as before, we'll put this through an FK transform and the auto rig component deform. If we hit enter into the viewport, there we go. This next one that we're going to use is a new one, and it's called the transform driver. And it's pretty powerful and pretty interesting. If we display that and I hit enter, you can see that we have some stuff going on already. We have our main control. We have this body control, which we can use to move everything. And then we have this limb offset control. If I move that up and down, you can see that it's offsetting the limbs. But how does this transform driver work? Well, like the others, it has these three basic parameters, and it's using the transform driver component. It's adding or updating our base rig, and it's using the guide source is guides.scale. So it has three I guess drivers, you could say. But let's just look at the first one here. On the settings tab, I'm saying I want to use transform, rotate, and scale. And then here, I'm defining what it is that I want to have driven by the control that I'm creating right now. Well, I want the root to be driven. So unlike our walkthrough earlier, the transform driver is going to give me the ability to move the root, but also a control for it. So I've specified the root joint, which is down there at the origin. And now I can say, how is that to be controlled? Well, the driver that I'm using is called main, and that's just a name that I've invented. And that will be what this thing is controlled. You can see if I mouse over, down there at the origin in white, it says main. And if I open up my selection sets here, you can see main. You can select that, and that is the controller that I'm using to drive the root. I'm saying, yes, make a control. You can turn that off, turn it back on. I think that little error is being finicky. Don't think it likes being turned on and off. So we can refresh this. This is the price you pay for being in beta. But you can see that I'm promoting translate, I'm promoting rotate, I'm promoting scale. Tags in this case is, do I want to add a tag to the control that I've created? So this is not tags that are incoming on our guide skeleton, but rather tags I want to add. And in this case, I don't need to add a tag. And then the last tab for the transform driver is the shape. What kind of shape do I want as my controller? In this case, circle_wires. What its scale should be. And in this case, I'm rotating it 90 degrees so that it sits flat on the XZ plane. And there we go. It's working. And so I've done the same for the core, which is one of the joints there in the center. And then finally, I'm driving anything with star_star_limb, which in this case is the name of the joints themselves, with a control that I'm going to call limb offset. You can see that here. And the location of that is the core joint. So that's going to sit just where this other body control is. I'm making the control, and I'm only promoting transform, not creating any tags, and the shape is a ball wire that's smaller than the other one. And so now with this control, I can move this around, I can rotate it, and I can scale it. I can select this and transform the whole body away from that main control. And then with this little limb offset control, I can lower the shoulders so that we have room to have kind of walking around activity. Or raise the shoulders in a kind of shrug, I guess. So that's the transform driver, and that's the kind of functionality that you can get. It's quite powerful if you have lots of controls that you need to just create this kind of functionality. You can stack these up and get a lot of work done with just this one control, or rather with this one auto-rig component. So next up, we're going to look at this look at control, which is a little more complex. And particularly during this beta time, I think earlier when I showed you that the interface is dynamically created and that it can be refreshed or cleared and rebuilt, that I think it was the look at that we used as an example. You could see how dramatic the change was in this interface. But let's have a look at this interface closely for our asset itself. On the first page, first tab, we have these settings. So a look at control essentially uses, or rather drives, the rotation of a joint to look at a target position, and uses an up vector to help determine how to do that. In this case, the up direction is the up direction, but target position here does not mean necessarily the target itself, but rather where this component should create the target. And we'll see how that is implemented in a second. And then for the driven, we've got a lot of stuff going on here. I know that the joint that I want to drive is here at the center of this sphere, and it's called dome. And so driven, I'm going to use a tag, and I'm going to find the dome tag. The parent of that dome tag is a joint called core. So I'm going to put core here in parent. And then for driver, this is a transform that is created by this auto-rig component. And so you want to give it a name, a meaningful name, so that if you were to look at it in the graph, you could find it and deal with it in some way. So this is a transform that the look at component is going to create. And this is what's going to actually do the rotation, and it's going to drive the dome joint. The kind of movement that I want to allow is rotation. So I'm going to driver promote R. There we go. And then the target, which is, if you remember from our skeleton, is this joint out here. So I want that joint to be the target that the driver looks at. So if we go back to our look at control, that's what I'm grabbing here. I'm saying find any joint really with the target tag and use that as the target. And then I want to promote that transform. I could specify another transform for my up, and I could promote some of its parameters. We have a look at axis. We have a look up axis if we want to change that. But for now, this will work for what I need. And display that, hit enter into the viewport to go into the animate state. You can see that the only thing that's changed from earlier is that we now have this square thing with the word target, and it can be translated. So now if I translate it, I can see that the dome and the turret is looking at the target. And you may not be able to see it, but if I mouse over here, you can see the dome driver. So this is a transform that has been created by this look at component. So it's this that is actually doing the rotation, and that it is driving that dome joint. So that is pretty cool. And then the other tabs on the look at component here are familiar. We have tags. Do we want to create tags on this newly created object? Transform, I should say. And then the shape. We can scale it, or we can give it a different color. Like I could give it green color. If I enter the animate state again, you can see there it is with a green color. So fairly straightforward. It's a little more complex than the others. You do have to sort of walk through what each of these is doing, because it's very reliant on a hierarchy, but pretty simple to set up. And then for the last one, we have this multi-IK. And this is where the real sort of procedural power of Apex and all of these properties and promotion and tags really come in handy. Because we did, admittedly, a little bit of work to create the attributes that we needed. But now, in a multi-IK, we can apply an IK to multiple legs all at the same time, because we're using these tags. So the multi-IK creates an IK, and we can give it a name. In this case, it's just IK, and it's operating on the guide source. But here are some settings about how our IK is going to behave. So we have dampening, stretch, the tracking threshold. That's how accurate the tip of the joint is going to try and get to the target. Do we want to use the twist? Do we want to use a goal? Are we going to resist being straightened? Do we want to level the pole vector, the tip, and the root? And these refer to these controls here. So this is a root, this is a pole vector, and this is a tip. The tip. So if I say level pole vector, you can see the orientation of this will change. So now they have oriented themselves according to the world axis, which might be useful for you. In this case, I don't want that, so I'm going to turn that off. And then pole vector offset, I can push them away or snug them right up close to the knee. That will depend on what your character looks like and how they function. And then we have, again, this driven tab, just like we had on our look at. But now we have two simple parameters. And these are the ones that are really doing the whole thing. Because what we're saying is, we want to drive some joints with this IK system. And how do we find them? Well, we're finding them with a tag. So anything that has the tag IK should be driven by the functionality defined here in the multi-IK autorig component. But we have 4 legs. So how do we deal with that? We deal with that by taking essentially the result of anything that has an IK tag, but also segmenting it, like that array of joints with that IK tag. We can segment them, group them, by saying use _leg to segment these joints. And if we go back and look at our tags, we can see that we have all of these have something _ leg. So if we say take this first part as a segment, then anything with L _ back is going to be these 3. So that is now a segment of all of our IK legs, or rather all of the joints that have the IK tag. So by preparing this earlier, we can very quickly provide this information to this autorig component. And we've built a rig for 4 legs automatically. You can see that they do in fact work. But if this character had 2 legs, this would work. If it had 2 legs and 2 arms, it would work. If it had 1,000 legs, it would also work, and it would be just that fast, because we're going to look for joints with certain tags. We're going to segment them with whatever this string is. And then once we have, essentially, this results in 4 groups of 3 joints. Well, 3 joints is all we need for an IK, and it will build that functionality onto those joints, resulting in a very fast and very flexible way of providing IK to multiple limbs. The rest of the parameters, tags again and shape, have to do with the shape of these controls, and do we want to add tags to these built controls? And in this case I do. I want to create an IK root tag on these root controls, IK pole vector, IK tip, because I might want to use them later to do something. And then parent, this is not hierarchical parent as in like a skeletal structure. This is more like this actual control out in the world here. What should it be parented to? What should the IK goal be parented to? So in this case, the root parent is the parent of the limb offset. That means any of these roots should be parented to the joint that is that limb offset. And so here, limb offset, all the roots have this as its parent. So now I can lower the arms, because all of these root controls have the limb offset as a parent. And similarly, all of the tips, I want to be a child of the root, so that I can select that root, move the whole thing around. But I can select the body control, and the tips stay where they are, so I can get this kind of crouching motion. So with the combination of the two, I can offset the limbs and then raise up the body. So now I have room for him to walk around. And so with a more procedural setup in mind, by creating these attributes based on what we intend for this character to do, what we intend to have as functionality on our rig, we define those things, many of those things, not all of them, but we can put lots of work here into the skeleton itself that is driving our asset, this guide skeleton. And then these auto-rig components will read, they'll look for those attributes and use them in a very flexible way. And you can see how, especially this multi-IK, we've built 4 identical IK rigs just in moments, really. And that we have control over how that IK is going to behave all in one node. So that's part of the real power and excitement about Apex, is this kind of functionality. And we can move on. We have a configure controls here, which is allowing us to make changes to the look of our controls. So I've changed some of the colors, some of their positions. And you can see that I've done 3 of those to the pole vector and the target, the IK targets, the root and the dome driver. You can also change the visibility of these controls. So if I didn't want to show those root controls on the IK, which I don't want to do, I can just turn them off, all with one node. I have access to all of these controls.